The Sun, a 4.5 billion-year-old yellow dwarf star, is a massive, hot ball of hydrogen and helium at the heart of our solar system. It is approximately 93 million miles, 150 million kilometers away from Earth, serving as the primary source of energy for our planet. Without the Sun, life on Earth would not be possible. Despite its seemingly unchanging presence in the sky, the Sun is a dynamic entity, constantly evolving and exerting its influence throughout the solar system. This fascinating field of study, known as heliophysics, seeks to understand the Sun's complex behavior and its impact on the solar system. The Sun is the largest object in our solar system, with a diameter of about 865,000 miles, 1.4 million kilometers. Its immense gravity keeps the solar system together, ensuring that everything from the largest planets to the tiniest bits of debris remains in orbit. Despite its critical role, the Sun is an average-sized star. Astronomers have discovered stars that are up to 100 times larger. Moreover, many solar systems contain multiple stars, unlike our single star system. Radius, approximately 435,000 miles, 700,000 kilometers. Mass, equivalent to more than 330,000 Earths. Volume, it would take 1.3 million Earths to fill the Sun. The Sun's closest stellar neighbor is the Alpha Centauri triple star system. Proxima Centauri, a red dwarf star, is 4.24 light-years away, while Alpha Centauri A and B, two Sun-like stars orbiting each other, are 4.37 light-years away. The Solar Nebula Hypothesis. The Sun's formation is a testament to the processes of cosmic evolution. About 4.6 billion years ago, the Sun emerged from a giant, rotating cloud of gas and dust known as the solar nebula. This process can be broken down into several key stages. Under the force of gravity, the solar nebula began to collapse. As it did so, it spun faster and flattened into a disk shape. Most of the material from the collapsing nebula was drawn to the center, forming a protostar, which would eventually become the Sun. This central mass contained 99.8% of the solar system's total mass. The remaining material formed a flattened disk around the young Sun. This disk, called the protoplanetary disk, eventually gave rise to the planets, moons, asteroids, and other objects in the solar system. The Sun's formation, from a swirling cloud of gas and dust to a stable, shining star, is a remarkable story of transformation driven by the fundamental forces of nature. The Sun is a vast, intricate system composed of several distinct layers, each playing a crucial role in its dynamics and energy production. At the heart of the Sun lies the core, where temperatures exceed 27 million degrees, 15 million degrees C. Nuclear fusion occurs here, converting hydrogen into helium and releasing immense amounts of energy. This energy is what powers the Sun's heat and light, approximately 150 grams per cubic centimeter, which is about 8 times the density of gold. Surrounding the core, the radiative zone is where energy is transported outward by radiation. Photons generated in the core take about 170,000 years to pass through this layer, extends from the core to about 70% of the Sun's radius. Beyond the radiative zone, the convection zone is where energy is carried by convection currents. Hot plasma rises towards the surface, cools, and sinks back down to be reheated, creating a dynamic and turbulent region. Temperature drops below 3.5 million degrees, 2 million degrees. Photosphere. This is the visible surface of the sun, emitting most of the light we see. The photosphere's temperature is about 10,000 degrees, 5,500 degrees, significantly cooler than the core, approximately 250 miles, 400 kilometers. Above the photosphere lies the chromosphere, a layer that is hotter and less dense. It is visible during solar eclipses as a thin, reddish rim around the sun. Temperature ranges from 4,500 degrees F to 35,000 degrees. The sun's outermost layer, the corona, extends millions of kilometers into space. It is visible during a total solar eclipse as a bright, white halo. Surprisingly, the corona is much hotter than the layers below it, reaches up to 3.5 million degrees. Like all stars, the sun has a finite lifespan, currently estimated to be about halfway through its life. The sun is in the main sequence stage, where it has been for the past 4.5 billion years. During this period, hydrogen fusion in the core produces helium, releasing energy that powers the sun's heat and light. In approximately 5 billion years, the sun will deplete its hydrogen fuel and expand into a red giant. It will become so large that it will engulf Mercury, Venus, and possibly Earth. Eventually, the sun will shed its outer layers, leaving behind a dense core. This core will cool and contract into a white dwarf, marking the end of the sun's life cycle.
The sun continuously emits a stream of charged particles known as the solar wind. This wind creates the heliosphere, a vast magnetic bubble that extends beyond the orbit of Pluto. The heliosphere acts as a protective shield, safeguarding the planets from cosmic radiation and other interstellar particles. The sun undergoes an approximately 11-year cycle of solar activity, ranging from solar minimum to solar maximum. During solar maximum, increased solar activity results in more sunspots, solar flares, and coronal mass ejections. These phenomena can have significant impacts on space weather, affecting satellite communications, GPS systems, and even power grids on Earth. Throughout history, the sun has held a central place in human culture and mythology. The Latin word for sun, sol, is the root of terms like solar system. In Greek mythology, Helios was the sun god, influencing terms such as heliosphere and helioseismology. Ancient civilizations revered the sun, recognizing its importance for life and survival. The current solar cycle, Solar Cycle 25, began in December 2019. Scientists predict that solar activity will peak around July 2025. Understanding these cycles helps scientists predict and prepare for periods of increased solar activity. The sun's formation and structure are central to understanding not only our solar system, but also the life cycles of stars. Its dynamic nature influences everything from space weather to climate patterns on Earth. As we continue to study the sun, we gain insights into the fundamental processes that govern the universe, enhancing our understanding of other stars and solar systems. The sun is a testament to the intricate and powerful forces at play in the cosmos. Its formation from a swirling cloud of gas and dust to its current state as a dynamic and life-giving star is a remarkable story of cosmic evolution. As we look to the future, the study of the sun will continue to illuminate our place in the universe and the forces that shape our existence. The ongoing research and exploration of our nearest star not only deepen our knowledge of the sun itself, but also pave the way for understanding the broader mechanisms at work in the universe, highlighting the interconnectedness of all celestial phenomena.
That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.